Just like sound waves, light waves appear to shift in frequency as the object emitting them comes toward or away from you. Light from an object moving toward you will look slightly bluer. Light from an object moving away from you will look slightly redder.
When the light waves shift their wavelength toward the blue and toward the red and back toward the blue again as the star wobbles around, the shift is excruciatingly tiny. But it's that difference in the wavelength of the light waves coming at you that is what we measure, and it's what allows us to detect planets around other stars.
Using this Doppler technique, Marcy and Butler spent over a decade patiently studying 120 nearby stars for any sign of a wobble.
I went 11 years without finding a single planet, nothing. And no one was surprised by that. It seemed logical to everybody else that it was a fruitless, frivolous, maybe even lunatic exercise to look for planets of any sort.
But then, in 1995, came the surprise announcement from Swiss astronomers Michel Mayor and Didier Queloz that they had discovered a gas giant planet circling the star 51 Pegasi. Marcy and Butler rushed up to Lick Observatory on Northern California's Mount Hamilton to aim their own telescope at the star and see if they could confirm the Swiss team's results.
Yep. There it is. Looks beautiful. Paul Butler and I were shocked to see that the wobble of the star was precisely as the Swiss had said it was.
In 1995, astrophysicist Alan Boss was asked to review a paper announcing the discovery by two Swiss astronomers of the first planet orbiting an alien sun.
Reviewing this paper caused me a fair number of sleepless nights because it was pretty stunning what they had found.
Stunning because the Swiss claim to have found a Jupiter-like planet. But where Jupiter orbits the Sun in 12 years, this planet zipped around its star in only 4 days.
And that also meant that the planet had to be much, much closer to its central star, roughly 100 times closer than Jupiter is. And that just was hard to understand.
If it were dropped into our own solar system, this alien planet would orbit much closer to the Sun than Mercury, our innermost planet.
Being so close to the star means that the planet is being literally fried. The radiation from the star is incredible compared to what we experience here on Earth, relatively far from our Sun. So this was a completely unexpected discovery.
It was a planet that could not have formed there. Astronomers knew it didn't belong there. It was a planet that could not have formed there. Astronomers knew it didn't belong there. And that's what astronomers were asking themselves about these giant planets that they were finding.
51 Pegasi b wasn't just a freak of nature. It was the first of dozens of so-called roasters or hot Jupiters to be discovered in seemingly impossible close-in orbits. Impossible because the accepted theory for how gas planets form suggests that rock and ice in a disk surrounding a young star coalesces into a solid core that then accretes gas, growing larger and larger until it has cleared out all the planet-forming material in its area. This process can only occur at a distance far enough from the star where it's cold enough for ice to exist.
You can't form something that massive that close into its star. It needs to form past the snow line where ice can form. And in our solar system, that's about where Jupiter is, about 5 times further out from the Sun than the Earth.
So how could a gas giant planet like 51 Pegasi b form so scorchingly close to its star?
It was one of these things where I woke up in the middle of the night, and one night I said to myself, maybe what this means is that this object had to have migrated inwards from where it originally formed.
We now, I think, have an understanding that planet formation is an almost chaotic process, a sort of roll of the dice, with many planetesimals, wannabe planets, forming, building up, and a competition, a sort of gravitational musical chairs takes place, in which the planets compete for their own space.
In this competition, some planets are flung out of the solar system, and some are tossed toward the center. It's believed some planets crash and burn on their parent star, while others survive in a close but stable orbit. These survivors are the hot Jupiters. like a wormhole, there's another phenomenon that has never been discovered. But Einstein's general relativity laws allow for its existence. It's called a white hole.
While a black hole is an object into which things are falling and disappearing, rather like a sinkhole, a white hole is doing the opposite. Things are coming out. Things are coming out rather like a fountain.
A white hole is like the unicorn, an exotic animal that's never been seen before. A white hole is very similar to a black hole, except it runs backwards. Think of running the videotape backwards. Instead of matter falling into the event horizon, never to come out, matter falls out of a black hole. So it's the opposite, a time-reversed black hole.
Black holes, as we know, have now been understood to be out there in our universe, and so you might wonder whether the same thing's true about white holes as well. For example, quasars, when they were first discovered, were thought to be maybe white holes. Why? Because they seem to be producing a huge amount of energy. We now know that that's not the case. Quasars are actually powered by black holes.
If nature uses white holes, physicists speculate that they could have been an important element in the earliest stages of the universe, maybe even in the formation of the universe itself.